Importance of the hippocampus, neocortex, and amygdala areas of the brain with regard to long-term memory processing and retention. The objectives of this PowerPoint is to understand memory is extremely complicated. The question, where is memory stored, is too multifaceted to cover in one essay. There are different types of memory and different resulting areas that memory is stored. We will be focusing on explicit or conscious memory. Another objective is to understand the theory that explicit memory is processed in three main areas of the brain: the amygdala, neocortex, and the hippocampus. This is important in an overall understanding of memory. This theory suggests that there are multiple parts of the brain responsible for the consolidation and retention of long-term memory. Another objective is to address the literature supporting this theory and any possible weaknesses that this theory may have. To summarize the strengths and weaknesses of the sources presented to support this theory. Evidence source 1, importance of the hippocampus. One of the critical breakthroughs in our understanding of a conscious memory came from the study of Henry Moallison, a patient who had most of his hippocampus and part of his amygdala surgically removed in 1953. Post-op, Henry displayed an inability to create any new long-term memory, with his memory limited to a short-term 30 to 60-second window. However, revised motor functions were retained, suggesting a different part of the brain was responsible for the retention of these unconscious memories. Henry showcased that retention of long-term memory requires a healthy, functioning amygdala and hippocampus. Autobiographical information and world information were shown to both be processed in the medial temporal lobes. However, consolidated autobiographical information resided permanently in the medial temporal lobe, whilst world information resided in the cortex, resulting in the retention of this information despite damage to the hippocampus. Evidence source 2, role of the amygdala in memory. People can accurately recall memories of stressful or emotionally charged events. For example, what they were doing when 9/11 occurred, long after the occurrence of the event. Neuroimaging studies have shown increased release of hormones that increase amygdala activity during periods of heightened emotion. Rats that were electrically shocked with an inactivated amygdala showed no sign of recalling the negative experience when exposed to the same stimuli in laboratory experiments, despite the emotional, stressful nature of the event. The amygdala can cause immediate processing and retention of long-term memory in the cortex due to increased hormonal activity. The long-term retention of memory is subject to variation, depending on the interaction between the hippocampus, neocortex, and amygdala. The neocortex receives memories regarding general knowledge from the hippocampus and is not critical for explicit memory retention. Evaluation of the evidence. Source 1 provided strong evidence about the role of the hippocampus to explicit memory retention, with a solid case study of an actual functioning human brain with this area removed. This allowed for long-term thorough study into the effects of this removal. However, the source was mainly observational. A more comprehensive approach with MRI and PET scans would have been preferable. Source 2 used both observational evidence and MRI and PET scans to create a cohesive argument for the role of the amygdala in explicit memory retention, with the only real weakness being the generalized view of what connotates an emotional event. The strength of Source 3 was breaking down the complex connections and processes that create explicit memory into simple, understandable language. This, however, resulted in a lack of scientific process being detailed. The reliability of the source is solely due to the institution it heralds from, rather than the scientific method. To conclude, the evidence presented strongly suggests that the hippocampus, neocortex, and amygdala areas of the brain are associated with the creation of explicit memory, and that long-term retention of memory is reliant heavily on the proper function and interaction between these areas. However, the sources do omit more complex processes regarding memory retention, and the idea that other factors may impact the formation of long-term memory. Despite this, I believe the sources reliably support the theory presented regarding the important role of the hippocampus, neocortex, and amygdala in explicit memory foundation.